Did we get the answer for this lab work? Okay. So, when you guys read the what we know, are those all things that I spoke about during class? It might not be written down in your notes, but were they things that were spoken during class? Okay? So, do you think that that's the hardest part on the lab work is the what we know? Trying to get the right, what do I write down? So someone was saying in the other class saying, I usually don't get full credit because I'll miss a point or two. Very true again, right? Okay. So how can I do that part? And then the other question is, how do we do with the work and understanding? Do we do okay with that, with the table? So what is it about the work and understanding that we're stuck on?
I mean, I just wasn't here for like that whole week, so I didn't know exactly what you wanted.
Okay.
So I would have never guessed you wanted a whole table like.
Okay. So did you look at the live lectures of those days?
Yeah, I did.
Did it not have a table on it?
I didn't finish them all. So I probably just considered.
So if you went to, so here's something I would suggest as well.
Like I looked at the notes, without like fully finishing like the full like live lecture,
Mm-hmm.
and I didn't. Yeah, see, I didn't see that.
In the notes part of it?
Yeah, I don't think that was there. So
That would have been on, no, not, maybe. Maybe that was the PDF was there, but the video might have not been there.
yeah, so I looked at the PDFs, and then I don't think I saw that part.
Okay.
And then I didn't finish it.
So if we didn't create a table like that in our like work, but like we kind of got it right, like am I gonna get dots points if I did not create a table?
Yes. Hold on. But the question is, how did you get that graph? Well, not that graph, sorry. That's the wrong graph, so you can't get that graph. So how would you get this graph without doing the table?
Well, like if I'm being tutored by my roommate,
Mm-hmm.
she learned a different way.
Which is?
I don't know how to just, I'm not really good with my words. Like I'm not good with the explaining what we know, so it's kind of hard.
No. The work on understanding.
I know, but like
I don't care about the what we know right now. Just the work on understanding. How did you get?
just plugging in different like numbers in the problem to be able to solve it. You know what I mean? Like I didn't create a table, but like she explained it to me a different way.
But you did.
It doesn't look like that.
Wait a minute. You said plug in different numbers. Isn't that making a table? Because I'm going to guess when you pick numbers, you pick different x values. You plug the x values in and find out what the y values were, yes? That is what the table is. You just got to show the work. Okay. Okay? If you write down, you know what that means? It means that wherever x is, I'm going to replace it with that. That's what that means. Okay? Now, if you're to write You were making a table. But the problem is that if I was to find f of 1, which equation would you use? The top or the bottom? X is less than 1. Does it include the 1? X is greater than or equal to 1. Does that include the 1? So therefore, this does not include the 1. This includes the 1. So if I find f of 1, I'm using the second equation. Anything that's less than 1, I'll use this equation. Anything greater than 1 or equal to 1, I'll use this equation. Make sense? So that's the reason why I wouldn't use this. That's the reason why in class I use the table. Because now I'm separating it. And notice that the critical point or the shared value is the 1, so it shows up in both things. But one of them is going to be open circle, and one of them is going to be a closed circle because it's included and one's not included. Right? So that's the reason why I did the table in class. Okay? Was it on the PDF?
I think like you put like the wrong PDF first and then changed it, and I took the notes off of the wrong PDF.
Okay.
So like it wasn't PDF, it just like
I know the video for the 6, I think I delayed putting up. The PDF, I think, was correct. So it might have been the other PDF you looked at. I don't know. Because obviously last week there's 2 sets of notes, right? One on Tuesday, one on Thursday. So the Thursday one was probably delayed. Okay. So here's the thing. Did I mention that this was a diagonal line? Do we know why this is a diagonal line? And can we confirm that that's a diagonal line? So why do I think that that's a diagonal line? What is it in that equation that I know is a diagonal line? X is to the first power, y is to the first power. That means it crosses the x-axis once and the y-axis once. Hence diagonal. Horizontal line typically crosses the y-axis how many times? That's why y is to the first degree. How many times does it usually cross the x-axis? None. So that's why a horizontal line is y equals. A vertical line crosses x once. Does it cross the y? No. So that's why it's a x equals, and there's no y in there. Parabola crosses the x-axis and the y-axis. So that's why it's a y equals x squared. Sideways parabola crosses the x-axis, y-axis. That's why x is to the first degree and y is to the second degree. Right? Those are all in the notes that we talked about those. That's why I know that this is a diagonal line, because x to the first degree, y to the first degree. I know this is a horizontal line because it crosses the y-axis once and the x-axis no times. Right? So that's why I know those things, right? And that's the reason why we need to determine what type of equation it is, what's the shape of that graph. And if it's linear, we only need 2 points. If it's not linear or curved, then we need 3 points, right? So let's say I have no clue how to do this. Day 1, what are some of the suggestions I gave you? In case if Chan put the notes up late and the video up late, what other things could I do to help me get there?
I just ended up asking ChatGPT.
Great. Great. Let's do this. I'm going to close out ChatGPT so I can reopen it. And let's do that. Was I supposed to yell at you because you said you used ChatGPT? No? Okay.
So sometimes ChatGPT is wrong.
I absolutely agree. I don't disagree. I do not disagree whatsoever. I can't say that it is always right. Oh, I'm out of uploads. All right, I guess I'm going to have to just use what was done before. So I shot it right out going, what are the general information I need to know to graph number 2? Right? I took a picture of it. Okay? Now, should we just copy and paste this into our work? Because if we do, what is it? It'd be cheating. Now, I do believe it is my duty as a professor to explain how to avoid that fine line. And I agree with you. Sometimes chat is wrong. Absolutely. But here's the thing. When you guys go through this and you're going, this sounds nothing like what Chan presented in class, you should raise your flag.
I say, can you explain to me why you got this answer and how you got this answer?
Okay. And what did it?
And then it explains it, and if I still don't understand it, I make it ask me again and say, can you explain in layman terms?
Yep.
How you got this answer?
So remember the first day I said you got to self-advocate, right? So let me give you an example of what I mean by self-advocate. All right. Actually, I'll give you an example of how I advocate for my father. So towards the end of my father's life, he was in the hospital, and they were watching him because he banged his head, and he was diagnosed with cancer already. So I come to find out that the doctor has decided to draw blood from him every hour. And he's already in there because he's tired. He doesn't have any energy, low on iron. And now every hour on the hour, they're drawing blood. So I'm like, this doesn't make any sense. So I go to the hospital, I find the doctor, and I go, Doc, please tell me, why are we drawing blood every hour, on the hour? I go, he's going to die of one of two things, and one of them is going to be your fault. He's going to die from cancer, or better yet, because you're drawing blood from him every single hour, he's going to die of not having any blood. He goes, I was thinking about that. Great. And you decided to change that when? Until I came in to give you your attention to it? So they stopped. I'm like, are you going to put some of that blood back into him or what, right? Like, so you guys got to do the same thing. If I came in with a bunch of zip ties and saying, okay, everybody, let's zip tie our arms together behind our back, are you guys going to say, okay, let's do this? You're not, are you? Fashion me late. So I'm going to ask one of you guys, go be like, well, can I go use the restroom and I'll come back and zip tie my arm, and then you're going to leave and you're like, hey, something's wrong. Something's terribly wrong right now. I need help in this classroom because he's having us zip tie our arms behind our back. Right? Does that make sense? Right? You got to self-advocate. So if chat is not giving you what you need, you ask it more. If you guys open up the lab work early and ask the questions to me, guess what? I'm going to explain it. I'm going to do the problem. And if something I don't do, something I do that you're not understanding, what are you going to do? Ask more questions, right?
What if you still don't understand after doing all of it?
This is where you need help. So when I was sitting in your seats, I definitely hit a lot of walls with engineering, also with math. My study group is what helped me. Because what the professor, I call it professor language versus student language. I can say the same thing to you, and she can say the same thing to you, or he can say the same thing to you, and you'll understand them way better than me, even though we say the same thing. I know it's tough, right? And I don't have a problem with you going, let's try a different explanation. Right? The problem with different explanation is going to be this. The problem with different explanation is going to be this. You're going to see a similar problem, and you're going to do it one way. You get the next similar problem, you're going to do it another way because the other way you understand better. Then you get to a similar problem, you're like, oh crap, I don't understand how to do it either way. But it's a similar problem. And that is when things go bad. When you have 5 different ways of doing the same problem or same type of problem, that's where I feel that things go bad. Neither way is wrong. But when you have so many different ways, you start getting confused. The best thing to do is to get a similar problem and keep on doing the one way. And then say, Chan, where's my speed bump here? Why am I getting this? Why am I getting stuck right here? Where is my thinking wrong? And typically what we do is this. When we get stuck, we abort. We find another way. We abort. We find another way. The problem is that all of those ways are still stuck in us. That's where our issue is coming into play. Rather than saying, okay, I'm stuck. I need help getting through. Okay, I got through. Let me try again. Am I getting stuck in the same place? Or am I getting through? Am I getting stuck in another place? Fine, let's work through that. Right? That is where I find, so for example, one of my students. So she will literally watch my videos, still confused, decides to watch other YouTube videos. I don't care. I'm good. I don't have a problem. The problem is that because of the different methods that they're showing, she's even more confused. And that's where she was. So that's where she needed to stop. I'm like, the problem is that you have like 5 different ways of doing the same problem. And that is where she decided, okay, I need to stop. I need to just trust the process. And I need you to keep on figuring out where my speed bumps are or what is slowing me down and figure out how to get through that part. Once she got through that part, she was fine. So she's like, okay, let's try again. She got through it. It was a little slower. She went through it again. Because one of the things I said to her was, because she had a military background. I said, when there's an operation and you got to go, do you have like 3 leaders coming to you and saying, this is the plan? And all 3 are different plans? Because how confusing would that be? The operation would be screwed because it's 3 different plans. That's why it's only one person saying this is the plan, and everybody stays with that plan. And then if they're running through the thing in their head, they're like, I don't understand this piece right here. At this location, I can't see the path forward from here. That's why they talk through those things. But everybody has to be on the same path, same plan. So, and I'm not saying that you have to do exactly what I'm doing, but I'm telling you that I need you to, or all of you guys, to at least try and then ask the question of, how do I get unstuck? Where am I getting stuck? How do I get unstuck? Where am I getting stuck? How am I getting unstuck? Okay? So I don't mind helping you guys through that piece of it where you're getting snagged on, right? Like, for example, notes were late, didn't see the table, didn't do a table. Okay, so you ask chat, right? So I asked chat, this is what it gave me, right? So this might help me with the work and understanding, but how does this help me with what we know? Can I write this down in what we know? No. Why? Well, it would be cheating, but what if I just... Now, I won't be learning anything, and it's too specific, right? Yeah, there's no guideline for a different problem. So, because all the numbers in the problem are in here. True? Okay. Look at my next question. Is there any 1s and 4s in here? Or -1?
I'll ask him the question, and then I'll be like, all right, what do I need to know to be able to solve this? What type of problem?
Yep.
And it'll give me.
And sometimes it still gives you numbers in there, and then you just say, hey, I need it to be more of a general guideline for a similar problem, right? Because you guys heard general before, because that's the description of what we know. Guide was something that someone used that I really liked, and similar problem I used before, right? So, because of poor Susie Q, right? Now, yes, same thing. If you copy this, it'll still be considered cheating. But what you should do is take this, take what you heard in the notes, and put them together. And saying, how would I using these words and his words, how do I explain it to Susie Q? That should be the what we know. Is that fair? Now, someone from yesterday's class said, well, I usually skip 1 or 2 steps, and that's why I don't get full credit, because those 2 steps typically are obvious to me. But I don't think about it, it's not obvious to Susie Q. I was like, here's the cool part, is that this, chances are you're not going to skip those steps because it's there as well, right? Is it perfectly right? Chances are, if you ask it enough questions, it will get to the right place, all right? So I'm telling you guys that this is something that you guys ought to think about using, for sure. Yes? Oh, sorry. I said, can you give me more general guidelines that I could apply to a similar problem, right? So something that's a lot more general, more like a guideline, and to a similar problem. So now I should be able, if I was to paraphrase this, like if you were to paraphrase this on your paper, now you can go, okay, let me now go into the notes, right? Maybe I have to replay the video because, in fact, someone in this morning's class said, I typically go back into the videos of that section and saying, give me some nuggets to put down into what we know. But a lot of times we aren't willing to do that, which I don't blame you. Me, today, if I was a student, I would, right? When I was sitting in your seats, would I? Probably not either. But back then, there was no pre-recorded videos. We had a textbook, right? And this is, like back in my day, it was like people brought recorders and left it on the teacher's desk to record the lecture. Literally, that's what they did, to record, yeah. That was what was done back in the day. Yep. On the rotary phone. Oh, there was push buttons then, or dial someone's pager to say, call me, I need help, right? So, but that is what was done before, and people who recorded would play that recording back to listen, and to rewrite the notes. But that's only if someone actually can afford buying a recorder as well. Because those were expensive, especially the smaller ones, not the one that you plug into the wall and hit the play and record button at the same time. So I would tell you to write that down and then go, okay, let me pull up another problem and follow these steps. Can I do it? And if you're not sure where you're getting stuck, send your work to me. Send the question to me. Send your work to me. I'll try to help you. I don't have a problem with that whatsoever. Beginning of class, end of class, no problem whatsoever. Just let me know. Okay? Any other questions? You guys could have just zoomed in on one device. I would have known that you're both here, okay? Yes, I'm talking about you too. But thank you, though. Fair enough. Any other questions? Any other questions on Lab Work 5? Yeah. Okay. So no other questions. We're ready for notes. Oh, this is Tuesday, 1:30. There we go. Okay. Then let's start talking about transformations. So typically, the f of x is your given function. In transformations, we're going to call this the parent function. We're going to call this the parent function. So let's talk about some examples of parent functions. So parent functions typically have no frills. It's the bare minimum of a function. For example, for a diagonal line, we're just going to say y equals x, right? There's no plus or minus something, right? Not going to put another number besides 1 in front of the x, right? Pure and simple. The most basic diagonal line you can write down. Or you can say y equals x squared. What kind of graph is that? Parabola. This vertex is going to be at 0, 0, perfectly split by the y-axis. Y equals x to the third is a cubic. From your view, it's going to look something like this. Also centered in the 0, 0. Reflected through the origin. Okay. Now, someone in the last class said, Chan, can you graph these? And I said, sure. There you go. This is in week 6, 2.5 notes. This is given to you in the PDF, so you guys can see all of those. X squared, the cubic, the square root, the cubic, cube roots, right? And then there's other ones too, but most likely you're not going to see many of those. You're going to see mostly the top ones here. So let's keep on going here. So y equals the absolute value of x. That's going to look like a v. Y equals the square root of x. That's going to be a sideways parabola, but you're only going to see the positive side. And y equals the cube root of x. So those are some examples of parent functions. Questions so far? Parent functions. All right, so from the parent functions, if we were to transform these, you'll have a different function, which is g of x. So again, you're going to have a parent function, and then you're going to have the transformed function, or function to be transformed. I would tell you to put some space on top, above it and below it. Oh, why is A and D the same color? Should not be. There we go. So you see the f, and typically we call it f of x. So inside that parentheses, it should affect what variable or what value? The x value. Everybody understand? So typically we call this f of x, right? So that's why everything inside the parentheses will affect the x value. Everybody see that? Sorry. It's backwards, opposite, and sad map. What do I mean by opposite? What in the world does that mean, opposite?
Whenever it's positive, it goes left. Whenever it's negative, it goes right.
So you're saying that every time it tells me to add, I should subtract. Every time it says subtract, I should add. And sad map is the backwards of PEMDAS. So the order of operation is even backwards. If it tells me to multiply I, if I divide, bingo, hence opposite. Is that fair? Questions? So everything inside the parentheses, backwards, opposite, sad map. So inside that parentheses, I see a B and I see a C. So Well, the C is going to talk about adding and subtracting. And it affects the x. So if I add or subtract from the x value, what am I doing with that point? Shifting left or right. Awesome. The A, I'm going to be multiplying or dividing. What is that going to do? And if I divide, if I multiply, so what's happening to me? In which direction? In the x direction. And the x direction would be which direction? This is the x direction? Wouldn't it be this way? Oh, I'm sorry. You're right. 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 Because I'm really talking about B, right? You're like, why are you talking about A right now? Because you're not even there. Yes, this will be a horizontal shrink or stretch. So please make sure you guys change that to B and not the A. Because I'm talking about inside the parentheses. Cool? Yes? So obviously if it tells me to multiply, I'm dividing, so that's going to be the shrink. If it's saying to divide, that means I multiply, therefore there's a stretch. So let's talk about outside the parentheses. Okay. What can you tell me about the outside of the parentheses? Mm-hmm. Is as is. Meaning it's straightforward. If it's telling you to multiply, you multiply. If it's telling you to divide, you divide. If it tells you to add, you add. If it tells you to subtract, you subtract. And in that case, there's the D and the A. What's the D going to be? Shift up or down. And the A? Thank you. Huh?
The D is kind of like your slope.
No. It's literally I'm taking the whole thing and actually shifting it. So that's what transformation is about. It's about actually taking it and shifting it. Yes. In terms of up and down. A vertical shrink and stretch and shrink. Horizontal stretch or shrink. And then the other thing is just shifting. Okay? Any questions there so far? We're good? All right. So the next thing is we see the F in there. And when you're asked to do transformations, they're going to give you the problem two different ways. And the two different ways is either like this, where you're going to see f. If you see f, that means the f has to be given. Okay? So let's say I give you f. So notice that in the graph is shown and it's labeled as f of x. Agreed? So that means, and what does f of x stand for again? What did I say f of x stood for again? Or a parent function, right? So that's the parent function. So can I name off those 4 points? Yes. So I'll write those 4 points down. So where are these 4 points coming from again? You're both right. It's a parent function, which is your f of x. Right? So, step 1, I got to find my 4 points from the parent function. True. We have completed step 1. We have found the 4 points from the parent function. Awesome. So now, point 2. We're going to look at the function. And what's the first thing I'm supposed to do in that equation? I got to do parentheses first. So I go inside the parentheses, and what do you see? X minus 1. So this is the first thing I got to do. Everybody agree? Sad math. So if that tells me the minus 1, that means what do I do? I got to add 1 to what value? The x value. So here we go. We're going to add 1 to the x value. Now I have new points. Any questions there? We understand that. What does that do, adding 1 to the x value? I think that's what you said. Shift right 1 unit. Right? That's exactly the word you said. Shift right 1 unit. All right. Is there anything else inside the parentheses to be done? No. So I'm done inside the parentheses, so I come out of the parentheses. Do I deal with the negative in front of the f first, or the negative 4, or the minus 4? Again, we're out. Ask a question. So if I come out of the parentheses, I'm back to PEMDAS, right? Parentheses, exponent. I got to do multiplication division first, then adding and subtracting. So that's the reason why we wouldn't do this first. I would go and do this part. Okay? So let me highlight that. So the next thing I'm going to do is this piece right here. And that is known as a negative 1, right? And it's going to be what operation? Multiplying, right? So what does that negative 1 affect? The y value. And since it's outside of parentheses, it's straightforward, right? As is. So I'm going to multiply the y value by negative 1. Does that make sense? Okay. What does that do? So this reflects over the x-axis. And if anybody goes, how do you know? Well, take a point. Take 3, 1, plot it. Now, look at what the other one is. It's still 3, but it's now negative 1. So since the y went from positive to negative, it had to flip over the x-axis, right? If the x went from positive to negative, it would flip over the y-axis. Make sense? And now, last but not least, what is this? So I'm subtracting 4 from what? Y. Why the y? Because it's outside the parentheses, right? Since it's outside the parentheses, it affects the y value. And it's straightforward. That's why I subtract 4. Question, does that make sense?
So let's say this, so to do D, it will always probably be over the y-axis because it's outside parentheses. So that will be the same for each problem we do, similar problem.
Anytime you negate the y value, it's always going to be a reflection over the x-axis because the y is going from positive to negative. That's why I was saying if the x went from positive to negative, it would be a reflection over the y-axis. That would be if it was right in front of the x. So it's still inside the parentheses, but it's in front of the x. Then that would reflect over. Okay? So as long as you guys realize what the order is, right? So if I was to look at this, let's say it looks something like this, right? I look at it, I go, okay, it got to shift right 1 unit. Oh, sorry for you guys. So shift right 1 unit, and then it flipped over, and then shift down. I need to be able to picture this.
Why is it shifting right?
Because it's opposite. So whenever this says -1, it's going to be to the right. If it says plus, it's actually going to be to the left. Sorry, right and left. So if I plot these points, oh boy, -5, 4, -1, -8, 2, 4, 6, 8. And there's your final product right there. Right? So you see the shift right, the flip over, and the shift down. Yeah. So yeah, anything that affects the x is going to be exactly opposite. So if it tells you to minus, it's the other way. If it tells you to multiply, it's the other way. What's inside the parentheses. Only what's inside the parentheses. Okay? Any questions there so far? Oh, I will. Because remember I said to you guys that it's going to be given to you in two ways, right? Of course. You think I want to avoid fractions? Come on now. So again, I told you guys it was going to be given in two ways, right? One is it's going to have f in it. If it has f in it, that means what? Parent function, but I have to be given what? The parent function, which means that my points are going to be given to me. No matter if it's from a graph, or they're going to provide the points, and that is going to be my starting point. Okay? So, if the f is given to you, if there's written f, that means something, a graph has to be given, the point has to be given to you, so you know where to start. Because the starting 4 points is always from the parent function. Okay? So with that being said, let's get to the next problem. Would this be enough? Sure, why not? We'll start here. So notice that I don't have an f in here. But I can figure out what the parent function is. How the heck do I figure that out? No. How about if I put it this way? Let me do a little sidebar here. What?
7 times 7? You don't do that?
You're talking crazy. So it's kind of a dead giveaway what the parent function is based on what's given to us. Right? If it's raised to a power 2, it's x squared. Power 3, x to the third. Square root, square root. Cube root, cube root. If there's absolute value, absolute value. So it's really like what's the parentheses, or what's being done to the parentheses, right? Right, the parentheses is getting squared, x squared. The parentheses is getting cubed, x cubed. The parentheses is getting, take the square root of x. Cube root of x. Does that make sense? So again, when I look here, I see this. So I already know okay? But I need to find my 4 points from what again? The 4 points I need to find is from where? The parent function, right? There's my parent function. How do I find 4 points? Oh, make a table. Plug things in. Okay, let's make a table. Dang it, people making tables again. All right. What values would you like to use? One? Okay. How about this? Negative 1, 0, 1, 2. It's only because you guys don't know any better yet, but we'll reflect on that. So I would tell you to do some negative, use some positive.
Always do 4.
Always 4. Unless the parent function doesn't allow you to find four points, then I understand if it's 3. Right? Okay, so what's the y value? Would be? Is that right? And I'll explain to you soon enough why these points would be bad. Besides 0, 0. 0, 0 is actually a very good point. The other ones are actually not so good point. Do we know how I got the 1, the 0, the 1, and the 4? Yes, because I squared it, right? Because that was the equation. That was the parent function, right? Y equals x squared. So I pick x values, random x values, and I square them. If it was cubed, I cube them. If it was square root, I'll square root them, right? Then I would probably want to pick 2, right? All right, so let's put those down. I got negative 1, 1, 0, 0, 1, 1, and 2, 4. Awesome. So now I look at the equation. Where do I start? Inside the parentheses, which says plus 7, which means I need to subtract 7 from what? All right, so minus 7, minus 7, minus 7, minus 7 from the x. And what does that do? Make up your mind, dude.
Shift to the right.
Because remember, you're subtracting, right? So it's got to be a shift left. Because you're subtracting, so you got to shift left. Are we okay there? Yeah? Okay. What's the next thing I got to do? The negative 1/3, because everything inside the parentheses is done. So the next thing is to multiply. Let's use green. ¿Por qué? I'm not dividing, right? It's affecting what value? The y, in a sense, is outside the parentheses. That means it's straightforward, as is. So if I tell you to multiply, you multiply. So I'm multiplying what?
So over the x-axis. So you're doing 1 times 1 divided by 3.
Okay, so you're saying multiply this by negative 1/3. This is why I was saying that these might be bad choices. I might want to pick x values that's going to give me y values that are divisible by 3. Right? So 0, 0 is fine. Maybe negative 3, which gives me 9. Positive 3 gives me 9. And maybe 6, which gives me 36. Oh, yeah. Because it'll be good. I'm sure that will be a great reminder of how we multiply fractions and add and subtract fractions. Since you guys love doing all of that, right? No? Negative 8, comma, negative 1/3. Negative 7, 0. Negative 6, comma, negative 1/3. And negative 5, comma, negative 4/3. So what does a negative 1, what happens when I multiply the y value by negative 1/3? I love the fact that you were just saying, you said the first thing, meaning you're separating the negation, the negative, and the 1/3. Okay? So what does the negative do? Flip it over the x-axis because the y went from positive to negative, right? What does the 1/3 do? Right? Vertically shrink it. Right? Because if the green giant just hammered his fist on top of my head, I'd be 1/3 of the size, right? So there's two things. Reflect over x-axis and a vertical shrink of a factor of 1/3. Right? And what's the last thing?
D.
We got to shift down 2, and that -2 is straightforward because it's affecting the y because it's outside the parentheses. -2, -2, -2, -2. How good is our math in subtracting fractions? What's negative 1/3 minus 2? Ooh. Here, I'll get this one.
Wait, -7/3.
Yeah.
Do that.
Here.
To get a math right now.
Here.
Will we have to do this?
Huh?
Will we have to do this?
You won't have to show all that work, no.
I know, but like, we'll pick different table numbers.
What is that, negative 10/3? So what did that do?
It went down 2 units.
Now again, when you see this problem here, and you see this being outside the parentheses, and it's affecting the y value, then I might want to pick y values that will be divisible by 3, or whatever else it is. Make sense? So that I'll end up with fractions. Right? And most likely on the exam, what will happen is that will be given to you, and then you'll be given 4 graph as choices. So if I think about a parabola, right? What did it do? It shift left 7 units. Then it reflect over the x-axis and shrunk, and it shifted down 2 units. If I can picture that, then I can pick whichever graph it is. Does that make sense? And when that shrink of 1/3, guys, I want you guys to think of it this way. So if you look at where my fingertips are, right? If I was to shrink 1/3, that means that height is now 1/3 of the height. It's not a shrink this way. It's a shrink this way, right? So when I was in 8th grade, the way I described myself in the 8th grade was that I was tall and short. Right? Because I was short, I looked taller horizontally. Oh, yeah. I was like a sphere. All right? And being shorter, you look fatter. And then when you grow taller, that same width doesn't look as wide anymore. Make sense? So this looked normal until it now it looks wide. Because it looks like a horizontal stretch, but it wasn't. It was just a vertical shrink. Make sense? So don't think of shrinking this way. Think of shrinking as literally the vertical side or the horizontal side. Okay? Any questions there? So do you guys see how two different methods, right? One is given the f. My parent function, my points from the parent function are given. However, when I'm not given f, I got to find out what the parent functions are, come up with the 4 points, and that is where my 4 points are coming from the parent function. Any questions there? Where do we get stuck? Good thing that you have decimals, huh? Oh. Yeah, I probably would have picked. Yeah, so I probably would have picked like -3, 3, and 6. So I would have had 9, 0, 9, 36. Because the 9 and 0 and 9 and 36 are all divisible by 3. Make sense? So this would be kind of like far out. Like it's like way out there. I understand, but we needed 4 points, so let's just throw that 4 point in there. Because if I was given graphs, I just really need to make sure that these 3 gets me to where I need to get to. I'm good to go. Make sense? And again, with the graphs, if you can picture it, knowing the order, you're like, okay, shift down or shift left 7, right? Flipped over, got shorter, which looks wider, and then down 2. Great. There's my graph. I can pick it. But you got to be able to do that in your head. Okay? Any other questions? But that's why you might want to look at. So there's nothing wrong with you given a problem, look at it and going, I'm going to pick these points, right? And go through it and say, oh, I should have picked different points, right? Like really evaluate and reassess.
So are we going to be given a problem where we don't have a parent function and what we just went over, what was the other one? So that parent function.
So if you're given f, that means some kind of graph has to be given or some kind of points have to be given to you to start, right? Because that, I have no idea what the parent function may be.
So we're always given f of x then to solve for g of x. It won't ever be like we only have g of x, so then we have to
Correct. Correct. You're never going to have to figure out what f of x is based on g of x, right? So like here, since I don't have an f, you figure out what f of x is, right? Because of that squared. And notice that in this whole thing, I didn't do anything with the square part besides that is the part that helped me find the parent function. And after that, it's like the square is not there.
Yeah, because then you just use that for your table.
Yep. And that's it.
Just make sure you do your table right. Pick easy numbers.
Bingo. At least the transformation, yes. And inverse, yes. And piecewise function, yes.
Guys, is that 2? Yes. Oh no, we didn't do that here. That was number 2 on the.
Did you miss last Thursday? So here's the deal I'm going to make with you guys about lab work 6. Sorry, lab work 5. 6? Okay, lab work 6. Here's the deal I'm going to make with you. Everybody that handed one in, I'm going to give 100%. However, yeah, the one that you just turned in, 5. I'm going to give everybody 100% that handed one in.
Why, nobody didn't do it?
However, this is what I'm going to ask in return. Because you know nothing's free. This is what I'm going to ask for return. I'm going to ask you guys to do the what we know better. That's all.
Can we bring you cookies and stuff? Or a bagel with or some fruits.
You can do all of that, but I still want the what we know better. You can do all of that for sure. But I'm asking for the what we know to be better. And again, I'm open for the ChatGPT to happen. But just don't cross that line of cheating. Just don't copy it down and saying, this has nothing to do with what Chan said, but here it is. Does that make sense? Because that's what happened in intermediate algebra. In intermediate algebra, here, let me show you guys this really quick. So in intermediate algebra, they had to do this problem right here, right? And they copied this down, which if you were to look at my notes, you would never see that line in any of my notes. Like, this has nothing to do with my notes whatsoever. And that's what they wrote down. So I said to them, where did you guys get it? Of course, they're not going to say anything, right? So I explained to them how to get out of it and how to be a self-advocate, okay? So other than that, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Thursday.